Welcome again to the Extractive Metallurgy course. And today is the class number 11. The number of the class, the name of the class is Hydrometallurgy of Gold. Remember, the last class we present the characteristics of the gold, the ores, the different characteristics of the ores, and the characteristics to extract the gold. But today we are going to make emphasis in the hydrometallurgy of gold. We are going to talk about cyanidation process mainly and some special topics about how to work with gold when we are going to dissolve the gold. It's very important because it's the main project, the main process to obtain the gold. Here I present some ideas, some methods that like the ore, like the gold, that don't are common bioxide. The gold, silver, and the platinum group. They are noble metals because they don't mix with the oxygen. And the main characteristic of the gold, the main characteristics of the gold is the gold is, as we presented in the last class, the gold is mainly is present in natural in different kind of ores. Mainly the gold is native ore without any combination of metals, but it's possible to find the metal inside the structure, the structural disposition of the sulfides, as pyrite, permutine, chalcopyrite, sphalerite, and the gold is inside the crystal structure, and it's very difficult to obtain or to release in order to take advantage of the gravimetric conditions. That's why it's necessary to use hydrometallurgical process to obtain. One of the characteristics, sometimes it's possible to obtain the gold or have the gold in some mixtures, in some compounds like tellurides. The gold tellurides are not very common, but they are present in different conditions, as we present in the last class. The main characteristic of the ore deposit is the association with different kinds of minerals, and it's important to define the mineralogical aspects of the gold ores in order to define the main process to obtain it. In that, this is the important topic. Define the type of the occurrence of the ore, which are the elements that are present in the ore. The particle size, as we presented in the last class also, and which are the main associations or mineral associations that are present in this ore. Uh, when you define that, you can obtain or you can define the process to obtain the ore. One of the points, as we said in the last class also, is the grind size. It's important to divide into visible goal and invisible goal. Remember that the size is between 1 micrometer to 10 micrometers. When you have minerals or element gold in size greater than with a size larger than 10 micrometers, it's possible to use a gravimetric process. When you have the size of the ball less than 1 micrometer, you need to use another process, and one of them is the hydrometallurgical process. This is what. Uh, and the other thing is that they define the characteristics of the nature or the minerals that are present in the ore in order to define which could be the characteristics of the metal. This imagine is important because here we can define characteristics of the gold, characteristics of the minerals, and in which are the types of the accompaniments, the particle size, and different associations that are present in the ore. Uh, about the goal, it's necessary to work to define the physical properties and some impurities could be present that could be difficult to make the salination process. When you have minerals that, as copper, arsenic, or iron, could be difficult to define the or to use the hydrometallurgical process. Uh, there are some properties about the gold that may easy or may define. And here I want to highlight the dissolution in cyanide. This is one of the characteristics of the gold. That's why it's possible to use cyanidation process as a very successful method to obtain the gold. Okay, here we need to define which are the requirements to obtain the goal. Which are the main characteristics that we need in about the whole in order to obtain the goal? It's important to define first, the goal is free. We have it's important to define. You don't have associations. For instance, though, it's not a good idea to have the rights in order to obtain to use these characteristics. The other important thing is to don't have present special minerals that could complicate the reactions because could be present another reaction parallel reaction that could difficult the situation. And don't have the presence of materials that could absorb the gold. When the gold is dissolved, some materials, as carbonaceous materials, could be precipitated the gold and reabsorb the gold, and this is a real problem in the process. Sometimes we have some minerals are present. And when the minerals are present, these special minerals are present, could be or could occur loud gold extraction. The time could be very long, and the high levels of consume of cyanide or consume of the reactions, reactants that are present. In that case, we say that we have a refractory ore. When we have a refractory ore, we will have problems in the process. In that sense, we need to define some special pretreatment that could be helpful to obtain the gold. But we are going to talk about that later in this presentation. Some of the pre-treatments that could be possible to use could be high temperature processing, like roasting, or maybe increase the pressure of the reaction, this pressure oxidation, or maybe use bio oxidation as an alternative to obtain the gold. Okay, but now let's talk about the gold dissolution. Gold, how could be the solution of the gold? We need to talk about that. It's necessary to pass the gold from the solid state to the liquid state. This is the key to dissolve the element. But it's not easy because gold is insoluble in the most of the acids solutions like sulfuric acid, like nitric acid, like chlorhydric acid is maybe impossible to dissolve the gold in that kind of acids. But a special combination of acids, chlorhydric and nitric, in relation 3 to 1, is named aqua regia. Aqua regia is a special solution that could dissolve the gold. In the past, some people use the aqua regia to obtain, but it's not a process that could be implemented in an industrial one. It's expensive, and the practical possibilities in the industry are not very easy. And of course, the gold is also it's possible to dissolve the gold not only in cyanide isolation solutions. Cyanide is the best option. Maybe sodium cyanide. Cyanide is the molecular that is composed by coal and nitrogen. This molecule is linked to a special alkalinous element like sodium, potassium, or maybe calcium. And they define a special element, a special material that could be very easy to dissolve. And another product that could be soluble is the Thiourea. Thiourea is organic molecular could be soluble. Exists another element that could be soluble, like thiocyanate, maybe the allurous elements, maybe they could be soluble as chloride, fluoride, bromide. They dissolve the gold, but the conditions maybe are not very easy. Uh, the most common cyanates are potassium cyanate, as I told you, sodium cyanate, and also calcium cyanate. They had the possibility, they had the characteristics that could dissolve easy the gold and create a new molecule. This sodium gold cyanate or potassium gold cyanate. This is the key of the process that we are going to do. The question is why sodium cyanide? Sodium cyanide because when you have sodium cyanide, this molecule is very have more potency, it's much potent. The active cyanide is higher in sodium than in potassium. Maybe we could use calcium cyanide. But calcium cyanide, the content active of cyanide maybe could be higher in calcium, but it's not very easy to obtain. The calcium cyanide is not very commercial, and maybe it's very common to have impurities that could change the characteristics of the product. Okay, as I told you, the gold could be dissolved in chloride in special characteristics in black aqua regia because we could create some special elements that would dissolve the element. And maybe then you use the chloride, maybe this, then you can use the nitrogen acid, nitric acid, in order to dissolve completely. Okay, but it's not very common, and the most important reactions that have been proposed to dissolve the gold are presented here. But the most characteristics, the most accepted reactions that can that in order to dissolve the gold is the Elsner solution and the Elsner reaction proposed by Elsner at the middle of the 19th century. And nowadays in this century, we accept the Habachi reactions. The Habachi reaction is this: is gold in presence of sodium cyanide with oxygen and with water produce a special complex, a special molecule of sodium and gold cyanide with sodium hydroxide and hydrogen peroxide. This is the complete reaction that we accept today in order to dissolve the gold inside. Some characteristics of thermodynamic characteristics of the reaction are presented here. Is accepted that thermodynamically, this is the point of view of thermodynamics, is possible, that the reaction is possible. Okay? It's important to define here what happened, which are the mechanisms when you put gold in presence of cyanide solution. The first is necessary to assure that the surface of the gold is clean in order to enter the cyanide solution and enter the oxygen. The first stage is an oxidation of the gold. Okay, the gold is oxide and is expelled or free an electron, and you have cathodic, the anodic area of the reaction. The anodic area of the reaction is the ball free. One electron is free from the ball. It means that the ball is oxidized. Then the cyanide enter, and the cyanide complex, maybe a complexion of the gold, and in that sense create the new reactions. The electron that is free from the ball goes to react with the water in order to create the hydrogen peroxide. Okay, this is the idea. This is the idea. And the global reactions produce the gold free. The gold is free, and is the gold free reacts with the oxygen, is oxide, make an oxidation process, and then the cyanide accomplish the gold and produce the molecule. That's why we present the Habashi reaction in order to define the characteristics of this reaction. Okay, how was the process? About the mechanism. First, you have a control, a diffusion control, because the cyanide and the oxygen ne- must go to the surface of the ball. This is the first control. Control for diffusion. Then we have a control because of the reaction. One control, a chemical control, because the goal may free the electron, and then the electron have to react with the water, the anodic reaction and the cathode reaction, and then the molecule that is produced with the complex have to leave. It's another diffusion control. Since the point of view of the cinetic, we have three different controls, the diffusion, the chemical, and the another diffusion. And you have to control. You have to control in order to define this situation. The chemical control is in a slow reaction. Okay, the reaction of the with the gold is an is difficult because it's difficult to oxide the gold. And in this sense, this is a very slow reaction. Okay, you could control the diffusion topics, the diffusion aspect, the diffusion controls with agitation, maybe. And maybe you control the reactions. Maybe you increase the reactions, or you control the cinetic topics of the reaction. Maybe increasing the agitation, that could be possible. In some topics, make that the oxygen enter to the reaction. Some people increase the pressure, and some people increase the quantity of oxygen in order to help to the reactions. But it's important to define that there exist different kinds of parameters that control the reactions. We need to control the reactions. And the most important now, we have at least five different parameters. One of them is the effect of the oxygen. Another is the effect of the concentration of the cyanide concentration. Another is the temperature. Another important factor or parameter that control the reaction is the grain size of the ore. It's important to define that. And finally, the effect of the alkalinity of the dissolution. These are the five parameters that control the reaction. And it's important to define. Okay, let's talk about all these parameters. Let's talk about this parameter that control the reaction. First is the oxygen concentration. Concentration. Oxygen is very important, as I showed you in the Hawachi reaction. You need oxygen because you need to oxide it. You need make an oxidation process with the gold, and you need to define that exists enough quantity of oxygen in order to define that it's possible to have the reactions in order to oxide the gold. Here I present a table about the different percentages of oxygen that could control the speed or the dissolution velocity of the reaction. It's important to define when you have the pressure, you increase the pressure of oxygen, it means you have more oxygen in the reaction. Maybe you could increase the velocity of the dissolution. Okay. Another very important topic, very important aspect is the concentration of cyanide. When you increase the concentration, you have to be close to the stoichiometry of the reaction. You need enough cyanide in order to guarantees that the reaction is possible. If you have a very low, less cyanide than you need, maybe could be possible to the cyanide don't accomplish the goal. This is necessary to have. We are working, that's very common to ore in the industry, depending on the condition of the ore, of course, or 2 kilograms of cyanide for ton of ore. Two, that could be three, that could be 2.5. It depends on the conditions. Some people in some conditions maybe use more, use 4 kilograms of cyanide for ton of ore. In some cases, people use more than five. It's not recommended, but some people use that. But look at this. The key in this process is doesn't exist recipes. No, every material is different. Every condition is different, and you have to define the characteristics of you, or to define the characteristics or the quantity of cyanide you need to use. Okay. The third parameter is the temperature. Temperature is, of course, you increase the, maybe you could increase the cinetic of the reaction, increasing the temperature, but not necessarily is continuous. But we have detected that in the literature is related, it's highlighted that until 195 Fahrenheit, maybe if you increase the temperature more than that, maybe the velocity could mm, go down. Okay. This is one of the figures that shows that the cinetic could increase, increasing the temperature, but not necessarily all the time. But the common is to realize the cyanidation process at room temperature. This is the most common. The most common is to use the temperature, use the room temperature to work. Okay, the fourth parameter is the particle size. It's important to define that because you need to, in order to use cyanide to obtain the gold, to make the cyanidation process, you need to have the gold in the small particles. Small means that less than 1 micrometer. You have the gold very bigger than that, maybe cyanidation is not a very good idea. You have to define that your goal is in a small size in order to have a good process. Okay, and cyanidation is a very good method to obtain the gold that is inside the sulfides. Is in the in the structural disposition of the sulfides. This is the best option. Or you have gold very fine and small. Okay, and of course, when you make the reactions with the cyanide reaction with the gold, it's possible to have the reaction with another metals like silver or another elements. Okay, and the five parameter that is important to consider is the alkalinity of the solution. When you are going to work with cyanide, you need to work in an alkaline solution. Alkaline means to have more close to pH close to 11. Okay? And it's necessary to define these characteristics because when you work in a pH lower than 11, maybe it's possible to create a reaction or disagree the molecule of cyanide and create cyanide acid. Cyanide acid is a very dangerous poison, and you need to avoid that. You need to work with the cyanide, with the sodium cyanide, and you need the molecular of cyanide, but you have to avoid the presence of cyanide acid. It's very complex that you need to increase the quantity of gold recovered or gold dissolved, and you need the cyanide in best condition to work. Okay, this is most important. And you need to work in alkaline conditions in order to avoid the presence of acids. Also, is important, and avoid the hydrolysis of the solution. Hydrolysis of the as of the cyanide, well, because when you have hydrolysis, the cyanide doesn't work. Okay, so the reaction stops, and at the same time, it's create acids, some acid that could be in the environment and are very poisonous. Okay, it's important to find. Since the point of view of the kinetic aspects, it's necessary to define the velocity of the diffusion or the velocity of the reactions, and in that sense, it's necessary to define the diffusion constants of the peak, to have the particle surface and the concentration of the ore in order the solution in order to define the characteristics. Okay. The velocity of the ball is not, as I told you, is not very high. It's a slow resolution, a small reaction, and when you have another elements like copper, maybe the velocity of the dissolution of the copper is higher than the velocity of the ball, and that could be difficult and it could be problematic for the solution. Okay, and it's important to define which are the characteristics to work. Not all the ores are possible to cyanide. You need to define some which are the characteristics of the ores in order to be or to have the possibility of the use cyanide to obtain the gold. First, you have the conditions in order to dissolve the gold. In that sense, you need the rock, the ore has been permeable to solution. The solution has to enter to be in contact with the gold and to dissolve really the gold. This is the most important. You have to be free of elements that consume the cyanide. So elements that have higher velocity of dissolution than gold. Maybe like if you have copper, we will have problems. That elements are not very good for that. Another condition is to have the size, the correct size to work, fine particles less with a size less than 1 micrometer, or to be in the structure on the crystallization of the sulfides or the elements that are in presence. Okay, don't have some acids or acidic solutions because you need to have alkaline solutions. Of course, don't have clay in the all carbonaceous materials, but because they consume the cyanide and don't permit the cyanidation process. Okay. Some elements that could be present are that are not desirable. You don't need to be there, or you must avoid the presence of it here are iron, copper, arsenic, or clays, or carbonaceous materials that could change the characteristics of the material or the element and maybe block the reactions. Okay, that elements could work in a condition and create refractory. Create refractory that avoid the dissolution of the gold. It's important to avoid that because it's necessary to work in a way. And the refractory could be physical or chemical. Physical is when you have a blockage, some characteristics that block the reactions. The gold is covered by some layers of materials that avoid the cyanide being touched with the gold. This is one part. This is physical refractory. But we could have chemical refractory. Chemical refractory as when you have some special elements like tellurium that exists the gold mixed or in a component with tellurium, named tellurures, as I told you in the beginning of the class. But you have to avoid that. How to work when you have refractory? The best option is try to make some pretreatments. Pretreatments that could avoid help you in order to obtain the gold, because when you have refractory, you don't it's not possible to have the reaction, the cyanidation process, and to avoid the recovery of gold. Okay, some of the pretreatments could be in high temperature, like roasting. Roasting breaks molecules. It's possible to use to obtain another molecule that could be easy to have the process cyanidation process. Or another pretreatments are hydrometallurgical treatments, pretreatment really. Maybe some of them is a very an oxidation process with potassium permanganate, with some special acid like chlorhydric acid, sulfuric acid, or nitric acid that could prepare the mineral in order to avoid the presence of these kind of elements that are in the ore. And the idea is to be in touch with the mineral. Okay. And the other is the biological. Another is which is used biological processing, bioprocessing, bio-oxidation, or elements that could change the characteristics of the mineral. Okay. Okay, this is the first part of the hydrometallurgical process, as we explained in the hydrometallurgical topic. We need to do the second part. The second part of the hydrometallurgical process after the cyanidation is to make the precipitation. To make the precipitation is very similar as we explained in the last part of the class, in the class corresponding of that. The idea is you in this moment you have a solution, a cyanide solution. The gold is in solution, the gold is in liquid phase. And now you have to precipitate the gold. You need to put the gold in solid state again. And this is a very common process named cementation. The cementation could be made with in the most common process is to you have the gold in solution and you put the gold or the solution in presence another metal. The most common metal here in gold solution is in gold precipitation is zinc. You put this gold solution in presence of zinc, and immediately you have a cementation process. The cementation produces the gold again in solid state, and the zinc goes to the solution. This is the reaction we have. You have the gold in solution, cyanide solution, put in presence of zinc, and then you obtain the gold free in solid state, precipitate, and then you have a special another molecule with cyanide with zinc. This process is usually in the absence of oxygen in vacuum. You need to create a vacuum for the solution, a vacuum condition, in order to avoid the presence of oxygen. In that sense, the name of this process is the Merrill-Crowe process. The Merrill-Crowe is the very most common process to obtain the gold. Exists also the possibility to obtain the gold not with sand, not with zinc, also with carbon, activate carbon. Activate carbon is a very common methodology in order to obtain the mineral and in order to define the characteristics of the mineral. This is the possibility of the work, and the idea is to precipitate the gold and obtain the gold. Okay, this is the main characteristic of the hydrometallurgical process to obtain the gold. And the idea is to talk about a little about the chemical of this process. This is a new topic about in the next class. Okay, Thank you very much for your attention. Thank you very much for being here in this course. I invite you to continue or be assisting, attending to this course. Thank you very much. Have a good day.